Okay, I think we're live. Let's check my audio.
And then this is just the notes.
I think we're good. Doing our audio checks before we get started. Let me plug this back into. All right. There you go.
Let's check my audio.
Audio looks good. We are ready to get started. All right, guys, welcome back to the live stream where it is just myself probably watching. But that is cool. This is my own study session. So welcome if you are watching. I missed yesterday's live stream, unfortunately, so I'm going to have to play a catch-up session just to make sure I get through all the content before I actually take the exam. But I'll probably do the catch-up session tomorrow because I am extremely exhausted as I did a double live stream on Wednesday. So today, we're going to do a bit of catch-up. We're going to do, instead of 1.5 sessions, we're going to do 2 sessions. And we're going to do section 6 and section 7. Section 6 is computer programming fundamentals and computational thinking. And then section 7 is fundamentals of data, including the characteristics, types, structures, and forms. So it should be a pretty fun one, very technical in nature, so it's more like specific. I feel like it's a little easier to do this type of content, but we'll just jump into it. Those are the ones we're going to do. So let me actually turn up the AC real quick, and then we will start getting down to business. All right. So let's start with computer programming fundamentals. These are fundamentals. These should be pretty simple. I did take a lot of computer programming classes back in high school, so some in college. So I know some, but you know, we gotta let's start off with good old Google, computer programming fundamentals, and see what Google says we should know. Let's see. Let me see what this was again. Computer programming fundamentals. So this is probably helpful. What is computer programming? 5. Oh, look at these. These are like some solid stuff. 5 fundamental concepts of programming. Let's take a look. Variables. You'll learn the basics. Yeah, this is pretty much it. I mean, this kind of ties in data structures into fundamentals of data. I feel like most computer programming classes actually start with teaching fundamentals of data, like the data types and stuff. Data structures is good. Syntax is really important. Let's go with the tools. Variables, of course. But yeah, maybe we'll just use this as the fundamentals. Seems solid. Probably like a coding boot camp. Yeah, this is a coding boot camp. Let me go ahead and cite this. Basic programming concepts. And we'll go ahead and actually use these. Actually, keep this over here. These things to start. So we are going to put in here go back here. Variables, control structures, data structures, syntax, tools. Okay. So let's see, computer programming fundamentals. Programmer's guide. Fundamentals of coding. Okay, what I'm gonna do is let's start with what is a variable. Let's do a little refresher here. Variables are the backbone of any program and thus the backbone of any computer programming language. I like to start off by defining what we're learning, so Wikipedia defines a variable as follows. In computer programming, a variable is a storage location and an associated symbolic name which contains some known or unknown quantity or information, a value. Okay, well, that's kind of cryptic. To me, a variable is simply a way to store some sort of information for later use, and we can retrieve this information by referring to a word that will describe this information. For example, let's say you come to my website, coderscampus.com. The first thing I want to do is ask what your name is so that I can greet you in a nice way the next time you visit my website. I'll put a little text box on the screen that asks you for what your name is. That text box will represent a variable. Let's say I called that text box your name. That would be the symbolic name or word for your variable as described from our wiki definition above. So now when you type your name into a text box, that information will be stored in a variable called your name. I would then be able to come back and say, what value does variable your name contain? And the program would tell me whatever it was typed into that text box. This concept is extremely powerful in coding and is used constantly. It is what makes Facebook and Twitter work. It's what makes paying your bills via your online bank work. It's what allows you to place a bid on eBay. Variables make the programming world go round. Now, if we want to get more specific, then it comes to the Java programming language. And variables have different types. And this is probably like the next section where it talks about like data types. Brace yourself here as I'm going to try to confuse you by explaining an important concept in 3 sentences. If I would be storing your name in a variable, that type would be a string. Or let's say I wanted to store your age, that type would be stored as an integer. Or let's say I wanted to store how much money you make in a year, that type would be stored as a double. What the heck are string, integer, and doubles? Excellent question. In core Java, the programming language wants to know what kind of information you're going to be storing in a variable. This is because Java is a strongly typed language. I could teach you about what the difference is between a strongly typed language and a weakly typed language, but that will likely bore you now. So let's just focus on what a type is in Java and why it's important. I can probably go more into data types. Oh yeah, this is what can you do with data types. Yeah, we'll come back to this. I think this might be a little too much information. Maybe most of the people who are studying for this course probably already knows these kind of fundamentals. So what I'm going to do is maybe just copy these parts, and this is probably fine for our purposes. And this is excellent stuff. If anyone, like the folks who are watching this kind of stuff probably are familiar with, the Epic EHR, and within Epic, I did the Chronicles. Chronicles is their database that they use, Chronicles database, and I did their programming course, and I didn't get certified in it, but I went through the entire course, and they always start with defining data types. It is extremely important to really understand your data types because we're basically managing data. Understanding what the data types are, how you can use them, how to manipulate them are extremely, extremely important in informatics. Okay, so that's variables. I think we cite? No, we didn't cite this yet. Let me go ahead and give this a cite. This was basic programming concepts. Very nice. So after variables, you ruined my syntax here. Here we go. Okay. Moving on to control structures. Let's go ahead and define. I don't even know what they're referring to with control structures. Let's see. Control structures. Hey, they don't have anything. Number 2. Okay. We've already discussed what a variable is, so let's now talk about control structures. A control structure is a block of programming that analyzes variables and chooses a direction in which to go on given parameters. The term flow control details the direction the program takes, which way program controls flow. Hence, it is a basic decision making process in computing. Flow control determines how a computer will respond when given certain conditions and parameters. Okay, so that definition is obviously a bunch of technical terms that no beginner to programming will understand. So let me try to describe it in more human terms. When a program is running, the code is being read by the computer line by line from top to bottom and for the most part left to right, just like you would read a book. This is known as the code flow. Now, as the code is being read from top to bottom, it may hit a point where it needs to make a decision. This decision could make the code jump to a completely different part of the program, or it could make it rerun a certain piece again, or just skip a bunch of code. You could think of this process like if you were to read a choose your own adventure book. You get to page 4 of the book and it says, if you want to do X, turn to page 14. If you want to do Y, turn to page 5. That decision that must be made by the reader is the same decision that the computer program must take. Only the computer program has a strict set of rules to control or to decide which direction to go. Whereas if you're reading a book, it would be a subjective choice based on whomever is reading that book. So this decision that must be made that will in turn affect the flow of code is known as control structure. I don't even think I remember that. Okay, that doesn't seem to be such a hard concept. A control structure is just a decision that the computer makes. So then that begs the question, what is it using to base that decision on? Well, it's simply basing its decisions on the variables that you give it. Let me show you a simple example. Here's a piece of Java code. If your age is less than 20 and your age is greater than 12, you are a teenager. Else, you are not a teenager. So you can see above that we have a variable and it's your age, and we are comparing your age to 12 and 20. If you're less than 20 and you're more, then you must be a teenager because you're between 13 and 19 years. What will happen inside of this control structure is that if the value assigned to your age variable is between 13 and 19, then the code will do whatever is inside of the first segment between the first two curly braces. And it will skip whatever is inside the second code segment. And if you're not a teenager, then it will skip the first segment of code and it will execute whatever is inside of the second segment of code. Let's not worry too much about what the code looks like for the moment, as I'll touch on how to write code out properly in section 4 syntax. The only concept you need to try and wrap your head around right now is that there is a way in programming to choose which lines of code to execute and which lines of code to skip. And that will all depend on the state of the variables inside of a control structure. When I say state of a variable, I just mean what value that variable has at any given moment. So if your age equals 15, then the state of that variable is currently 15. Cool. This is very helpful. Let me go ahead. Code structure. Oh no, control. They're called control structures. It's not very intuitive to assume that's what it means. But looping this back to AHIC, most of us are familiar with, it's as a pharmacist, understanding dispense logic, how one determines the dispensable to use is also understanding in which direction the AHIC will read the lines of programming that you put into it. Very, very important. So I guess in that case, that's a good fundamental concept to know. What is this? Computer programming fundamentals. Okay, so next one is data structures. I don't even know if we should cover that because the next one is fundamentals of data. So I think that I might skip that. And you know what? This might actually be fundamentals of data in terms of other things beyond what I'm thinking of computer programming wise. I wonder if they're going to structured and unstructured data too. But let's just take a look. Might as well just copy it. Data structures. What are they and why are they useful? Well, let's take a turn to a quick definition from Wiki. Let me see how long I've been streaming here. 13 minutes. What are they and why are they useful? I don't want to cover too much. I might just copy this section because I might look into the data structures for the next section. Where is data structures? Oh, you know what? They actually might be referring to something else. Okay, let me just read it. In computer science, a data structure is a particular way of storing and organizing data in a computer that it can be used efficiently. So it's actually not what I was thinking about. Okay, that definition is a little bit more down to earth, but there is a lot of meat behind data structures. Let me try to explain the point of data structures by giving you an example. Let's use a list of contacts as the example. You probably have a list of contacts somewhere in your life, whether it's in one of your email programs or address book in a kitchen drawer. There are a bunch of contacts, and that list of contacts could grow or shrink at any given moment. If you were to try and represent all those contacts as variables in a computer program, how would you need to do it? Well, there's a right way and a wrong way. For the purposes of our example, let's say we need to keep track of 10 contacts. First, the wrong way. If we need to store 10 contacts, we probably need to define 10 variables, right? String contact 1, 2, 3, 4, 5, etc. In the world of programming, that is just a terrible way of trying to store 10 different variables. This is because of two reasons. the sheer amount of text that you'll need to write in your program. Efficiency is important. Sure, right now we have 10 contacts, so it's not bad, but what if we had 1,000? Imagine typing that out 1,000 times. Forget about it. The flexibility of code. If we need to add another contact, we wouldn't be able to do it without manually editing our code. We would have to go into our code, physically write out contact 11, and then try to store whatever information is needed into the new variable. This is just crazy talk. So what is the right way? I'm glad you asked. It's a data structure, of course. In this case, we have a list of contacts, and with Java, there's a data structure called a list. Okay, so what does it look like? Here's the code. List contacts equals new array list. Again, let's not worry about all the symbols and confusing brackets and semicolon. We'll cover that later. All you need to understand right now is that there's a way to store a bunch of contacts into something called a data structure. In the case of our example, a list. Okay, so what's so great about a list? Well, for one thing, you can add and remove things from a list with ease. So if you start with 10 contacts, it's a piece of cake to add another contact to the list. How you ask? Just like this. Contacts.add John Smith. Voila, we've added another contact to our contacts list. So you may be saying the right way looks like just as much typing as the wrong way. You've got a point, but the main difference is that the first approach, you had to create 10 unique variables. With the second approach, we only created one variable, which is contacts. Because we only had to create one variable, and because we can say contacts.add, means that our code is much more flexible and dynamic. When I say dynamic, I mean that the outcomes of the program can change depending on what variables you give to it. That's really the key to using data structures. We want our code to be as dynamic as possible. We want it to be able to handle a bunch of situations without having to write more and more code as the day goes by. In essence, a data structure is just a way to get around having to create tons of variables. Now there are a bunch of other data structures in Java, but I'll just quickly touch on the ones we use most often when programming. The next one I'll talk about is the hash map. This doesn't sound as straightforward as our last data structure, the lists, but it's really just a fancy name for fairly simple concepts. Do we need to know about this? I guess I'll continue reading. What is a hash map? Here's a visual representation. Honda to Civic and Prelude, Toyota to Corolla, Celica RAV4, Ford to Focus and Mustang, Audi to R8. What you see here is the make of a car on the left with points to different models of that make. This is known in the programming world as a key-value pair. The key in this case is the make of the car, and the value in this case is the model. That is how a hash map works, and it's just another data structure. This concept is used all over the place on the web. For example, if you ever filled out a quote for automobile insurance online, you probably had to choose the make and model of the car. I bet you that information was presented on the screen using a hash map, just like I showed you above. Because when you select Toyota from one drop-down list, the second drop-down list will need to change its contents to only show models of cars made by Toyota. Then, if you change the first drop-down list to Honda, that second list would change again to show cars made by Honda. So how about I show you what a hash map looks like in the Java code. Map cars equals new hash map. Cars put Toyota, new array lists, arrays as lists, Corolla, Celica array. Interesting. Wow, there's a lot of stuff going on here, but don't be intimidated. All you need to understand right now is the concept that hash map data structure stores key value pairs. In our case, a make is the key in a list of value. A list of models is our value. Now that's kind of interesting. Did you see what we did here? I just said that we have a hash map data structure. Where is it? The new hash map data structure. New array list, car put Toyota. This is, so we have a hash map data structure, and inside the hash map we are storing a list, which is another data structure. This is done on a fairly regular basis in the programming world. We can use one data structure inside of another. So if the point of data structures is to help us minimize the number of variables we need to create, then we are really saving ourselves the hassle of creating a lot of variables. You know, I work with groupers quite often, and this is like a great example of the right way and the wrong way. You know, most people that I've experienced in the field of informatics, instead of thinking of things like this, like a data structure, or in most of the cases that I'm thinking about is like ontology, building and representing medical information in ontological forms, they just create a new one. And it is not objectively speaking from this, the right way of doing things. Cool. So we have data structures. This was pretty long. I'm like getting a refresher in programming. This is probably fine. Syntax is next. Let's take a look at syntax. Syntax. Okay, what is syntax? As always, let's hop over the wiki. In computer science, the syntax of a programming language is the set of rules that define the combination of symbols that are considered to be correctly structured programs in that language. All right, so I would say that it's almost English, but what do they mean by combination of symbols that are correctly structured? Well, I would choose a different word than symbols. I would define syntax to be a particular layout of words and symbols. An example of this, in this case of Java, would be round brackets, curly brackets, and variables, among other things. Think of it like this. When you look at an email address, i.e. johnsmith@company.com, you can immediately identify the fact that it's an email address, right? So why is that? Why does your brain make that connection that it's an email address and not, say, a website address? Well, it's because an email address has a particular syntax. You need some combination of letters and numbers, potentially with underscores or periods, in between, followed by an @ symbol, followed by a website domain. That is a defined combination of letters and symbols that are considered correct structured in the language of the internet and email addresses. So syntax in a programming language is much the same. There are a set of rules that are in place, which, when you follow them, allows your programming language to understand you and allow you to create some piece of functioning software. But if you don't abide by the rules of programming languages syntax, you'll get errors. How about an example of syntax in Java? Well, you've seen it already back when we talked about variables and control structures. To define a variable in Java, you need to do this. String hello variable equals hello everyone. There are 4 parts to the syntax of creating a variable in Java. The first is the word string. This is the variable's type. Remember when we talked about variable types in the first part of the series, I mentioned string, integer, and double. 3 different variable types that allow you to store 3 different kinds of data. A string in this case allows you to store regular letters and special characters. The second part to this variable creation is the variable name. In this case, arbitrarily chose hello variable. I could have easily chosen holy cow, this is a variable name. Variable names can be made up of letters and numbers, but the only special characters they can contain are underscores. They also usually start with the lowercase letter. They don't have to, but that's kind of an accepted and suggested convention, at least in the Java world. The third part of the syntax for creating a variable is the variable value that the variable will hold. In this case, we have a string variable, so we have the value hello everyone. In Java, strings are defined by wrapping regular letters, numbers, special characters, and quotes. Again, that's just the syntax that Java uses. The last part of this syntax is the part that makes this particular code segment as being complete. In Java, we use the semicolon to mark a part of our code as complete. You will see that almost every line of code in Java will end with a semicolon. Just look back, yep, semicolon. There are certain exceptions to this. For example, control structures aren't marked with semicolons as they use curly braces to make their beginning and end. Think of like putting a period at the end of every sentence. If we didn't put a period, we just have one long, unstructured, run-on sentence, and that wouldn't help us understand anything that's being said. So as I mentioned before, the syntax of any programming language will likely be your biggest hurdle as a new developer. But as you see more and more examples of code and are introduced to more and more syntax in the language, you will become comfortable. There's good news though, as people have realized that dealing with syntax can be tough, so companies or groups of enthusiasts, aka nerds, have created tools to help us with the syntax of programming language. These tools are called IDEs, or Integrated Development Environments, which you can download onto your computer and use to create programs. These IDEs have built-in syntax checkers, much like Grammar Checker in MS Word, that will let you know if your syntax is incorrect and will even give you hints with what it thinks you meant to put. So don't worry, I'll cover those tools in the next 5 sections. Another nice refresher on syntax. Syntax is always super important. I work within the Chronicles database in Epic quite often, so I use a lot of the different tools in Chronicles, and usually there is a particular a syntax that must be known to effectively use it. So I like syntax. Syntax is good. Okay. Last section here is tools. So let's go to tools. All right. Tools. Well, I don't think we need to go to wiki to this one, as many of you should know what a tool is. In the real world, a tool is something, usually a physical object, that allows you to get a certain job done in a more timely manner. Well, this holds true with the programming world too. A tool in programming is a piece of software that, when used while you code, allows you to get your program done faster. There are probably tens of thousands, if not hundreds of thousands, of different tools across all programming languages, but I'll focus on the main kinds of tools that everyone is likely to use. The first and foremost tool, in my opinion, is an IDE. An integrated development environment is a piece of software that will make your coding life so much easier. IDEs will check the syntax of your code to ensure you don't have any errors. They will organize your files and give you a nice way to view them, apply color schemes to your code so it's easier to interpret. They tend to have code completion, which will actually fill in some of the code for you in common scenarios, as well as allow you to navigate through your code easily. There are many other advantages of using an IDE, but I think you get the idea. In Java world, the IDE I use most often is Spring, STS. This IDE is free and full of free features. It's what I use whenever I program, both at work and at home. For the purposes of this Java tutorial, I will focus on just this one tool, as it will be the most important thing you use when you begin the program. So I'm not going to install this. I guess that's pretty much it. I think the main concept is fine. I almost want to think about, like, in website programming, for example, I use Squarespace, not sponsored, but Squarespace is fairly easy to use. You don't need to know any HTML or programming languages to build it. I used to build my own websites back in, hold on, this is like, make sure this is, I keep the same formatting here. What did I copy? Oh, yeah, this. Let me get rid of this. Here it is. Okay. Yeah, so I use Squarespace, and basically it sounds like an IDE seems like what Squarespace would be equivalent to. They just write the code for you, essentially. I might be oversimplifying it there, but I think this is it. I mean, this seems like a pretty straightforward fundamentals in general, like how computers think. And yeah, this is perfect. This is basically what I would think of too, in terms of computer programming. Obviously, right? No, this was a good refresher in some of the things that I didn't even know. Nice to be more formal about it. All right, let's move on. Fundamentals of data, including their characteristics, types, structures, and forms. Let's see. Fundamentals of data. No. This is all fundamentals of data science. That's not what we're looking for. Data characteristics, types, and fundamentals. Let's do that. Maybe this is fine. Let's take a look. No, I guess like what I was thinking about earlier, structured, unstructured is more so in terms of when they're talking about big data. Yeah, this is not what I'm trying to look for. Let me just like do data characteristics and types. How about that? It's too focused on big data. Let's do computer programming. How about that? This might be fine. Data types. see if there's another one. What is this one? The data type characteristics. This looks very more about data types. This is probably good. So this topic was data characteristics types, structures, and forms. I don't know what they want to say with characteristics. Characteristics. Characteristics, types, structures, forms. Maybe I'll just use this. This seems like straightforward enough. Character contains a single value. Syllabus detail. Data. So data type characteristics, and this is just data types. I wonder, what do you mean by data type characteristics? Data types are critical to a computer system in order for it to process data. The type or characteristics of a piece of data define how it can be processed. Oh, I think I know. What are the characteristics of a particular type of data? They also define the data's range and validity and how said information is stored. So basic data type characteristics. An integer has a range, specific storage, an example. Real data types are infinite numbers that can't be referenced by a computer. These include numbers as fractions or decimals. A character. Characters have no range. Storage is 1 byte. Examples are these. String, dependent on string size. Boolean, storage is 2. Example is true or false, 1 or 0, on or off. Complex data type characteristics. Man, this is a lot to type up, but I guess let's go ahead and do it. So what I'm going to do is, hold on, let me cite this. Data type characteristics. But let's first start off with data types. So let's go with data types. Paste without formatting. Common data types. This is gonna keep my formatting for me. Nice. Common data types. So data type and description. I'll probably get rid of this. Character, number, data type, date and time, text string, currency. Okay. There's text string, and then there's Boolean, true, false. This is cool. Okay. And then now let's take a look. Characteristics. I don't remember if I cited this already. Let me go ahead and cite data types. Let's do here, Zotero. Data type characteristics, no. Data type. And then we will do the data types characteristics afterwards. Go back. Yeah, some of the things when I think about, like, again, using Epic as a example, data types are really important because it can define certain limitations in the different things you're trying to build. Let's say you're building an order set. You know, some of the things that may be limiting is you can't pull in a record that's not a medication or a procedural order or a lab. You can only pull in certain things. Or some types of order sets, like an ambulatory order set, can pull in notes while a inpatient order set cannot. And these are things that are governed by the different data types within a or record type, actually, in those cases, in your system. So knowing these kind of things can really be important in knowing the limitations of a system. Basic data type characteristics. How do I want to do this? So let me copy the background, paste this in here. This is good. Yeah, that's not what I want to do. Basic type examples. I think what I'm going to do is actually just like take a picture of it. That might be easiest. Let's go ahead and take a picture of all this. I really don't want to type that or like copy it. I'm going to lose all the nice formatting that they have. Yeah, this is cool. It's just a little ugly with the... Yeah, it's too small. I think what we'll do is make two different pictures. Do one here. Make this one fit. And we'll do the next one. Complex data type characteristics. Yo, what happened? You like killed my picture. Maybe this doesn't work. I guess this specific snipping tool doesn't store my data. That sucks. I wonder if I needed to like save it or something. Okay, so I need to figure out what to do here. I probably need to save it then. So yeah, it's gonna save me time. So I'm gonna just save this on my desktop. This PC. No, let's save this in AMIA AHIC certification. Save this complex data too. Go back here. Save the basic data characteristics. So this would be an example of a data characteristic of pictures that I'm storing. Apparently, one of the characteristics is that it doesn't store more than one picture at a time. So now I need to save it. Cool. Let me now insert the image from computer. This is PC pictures, not pictures, it was in the AMIA AHIC complex 1. insert image 2. Cool, now we're set. Okay, so those are your characteristics and then your types. Let me just go ahead and give this a citation. Data characteristics. Oh man, I am exhausted. We are at 40 minutes. Let's see if there's any other things here. So we have data structures and then data forms. I don't know what people are referring to in terms of data forms, but let's take a look at data structures. Data structures. Oh, interesting. Data structures. A data structure is a collection of data type values which are stored and organized in such a way that allows for efficient access and modification. In some cases, a data structure can become the underlying implementation for a particular data type. For example, composite data types are data structures that are composed of primitive data types and other composite types, whereas an abstract data type will define a set of behaviors, almost like an interface in a sense, for which a particular data structure can be used as the concrete implementation for that data type. When we think of data structures, there are generally 4 forms: linear, like arrays and lists; a tree, binary, heaps, space partitioning; hash, distributed, hash table, hash tree; and graphs, decision directed, acyclic. Now let's take a look at the properties that make up a few of the more well-known data structures. So there's so these are data forms. Maybe this is what they're talking about. So there's data forms and then there's data structures. Let me go back up. Did they talk about data forms up here? Oh, this is actually a really good reference. Hold on 1 second. Abstract. This seems way more thorough of a thing. So data form. Let me actually search that up. Is that what they're talking? Data form. What is data form? No, that's not what they're talking about. Data form. Data characteristics, types, and forms. No, I think I'm just going to use this and cite this as the form and the data types and structures. I really like that way he described it. So data structures. Let me just group data structures. So let me go ahead and copy and paste this. So let me do structures and no, and actually do forms. Let me put it down here. Okay. So these are the types of forms. And cite this as data types. And then we're going to go ahead and look through so that we're talking about data structures. So let's read through some of this. An array. An array is a finite group of data which is allocated contiguous, sharing a common border memory locations, and each element within the array is accessed via an index key, typically numerical and zero-based. The name assigned to an array is typically a pointer to the first item in the array, meaning that given an array identifier of ARR, which was assigned the value ABC, in order to access the B element, you would use the index 1 to look up the value ARR1. Arrays are traditionally finite in size, meaning you define their length and size, i.e. memory capacity, up front. But there's a concept known as dynamic arrays, and of which you're likely more familiar with when dealing with certain high-level programming languages, which supports the growing or resizing of an array to allow for more elements to be added to it. In order to resize an array, you first need to allocate a new slot of memory in order to copy the original array elements values over to. And because this type of operation is quite expensive in terms of computation and performance, you need to be sure you increase the memory capacity just the right amount, typically double the original size to allow for more elements to be added at a later time without causing the CPU to have to resize the array over and over again unnecessarily. It's a lot of information. So cool. We get what an array is. A linked list. A linked list is different to an array in that the order of the elements within the list are not determined by a contiguous memory allocation. Instead, the elements of the linked list can be sporadically placed in memory due to its design, which in that each element of the list, also referred to as a node, consists of two parts, the data and a pointer. Data is what you've assigned to the element in node, whereas the pointer is a memory address reference to the next node in the list. 12 to 99 to 37. Also, unlike an array, there is no index access. So in order to locate a specific piece of data, you'll need to traverse the entire list until you find the data you're looking for. This is one of the key performance characteristics of a linked list, and is why, for most implementations of this data structure, you're not able to append data to the list. Because if you think about the performance of such an operation, it would require you to traverse the entire list to find the end last node. Instead, linked lists generally will allow only prepending to a list, as it's much quicker. The newly added node would then have its pointer set to the original head of the list. A tree. The concept of a tree, what forms are these again? Tree is it doesn't really say. Tree is to represent a hierarchical, I know what they're talking about. Tree structure with a root value and subtrees of children with the parent, representative of a set of linked nodes. So very similar to a hierarchical database. A tree contains nodes. A node has a value associated with it, and each node is connected by a line called an edge. These lines represent the relationship between the nodes. The top level node is known as the root, and a node with no children is a leaf. If a node is connected to other nodes, then the preceding node is referred to as the parent, and the nodes of the following are its child nodes. There are various incarnations of the basic tree structures, each with their own characteristics and performance considerations. Binary tree, binary search tree. This is a lot of freaking information. I think what we can do, I don't think we want to go through all of these. I think if we copy and paste all this would be quite a bit. So I think what we'll do is for a detailed description of the various of the more common types of data structures, review this reference. We will do that, and you can read through it. That's good. Go ahead here, and I'm going to reference. Why did it kick me out of Zotero? I can't believe I streamed for almost an hour again. Data types. I'm really tired, but I think we got through it. We got through all the data types, characteristics, and structures. This is really interesting and good, review of very technical terms that I just haven't reviewed in a long time. But also the fact that I actually need to review it, or that I'm just spending time, my free time on a Friday night, going through this. blows my mind. Data types. Cool. I think that's it. This is was a fun session. Got through both sections in less than an hour. Pretty solid. Had a nice fun review. I always enjoy reading about computer programming, even though it does tend to get a little dry if you spend too long on it. I gotta mix it up with other things sometimes. So I think that's it. This is good review. Tomorrow I'm gonna be doing a longer live stream session just to cover, what was it, tomorrow's 11/12. I need to cover 3 sections tomorrow to catch up. Basic database structure, basic systems and network architectures, policies and procedures for data sharing. Now it's getting into more like health information technology type stuff. So yeah, I'll do that tomorrow. I'll do a longer session. Probably do like an hour and a half on weekends and then just an hour on weekdays. But that's it, guys. Thank you guys for tuning in. Just probably like one other person and myself, whoever you are. Cool. We'll see you tomorrow. Bye.